think from a scientist perspective, you're really disconnected from the business world. When you establish a process, you need to consider like your costs. And this was a completely new journey for us, having all these considerations. What are the costs? What is available? What does the regulatory approval look like? And I think only if scientists are also get some education on that, only then the two worlds can be connected.
Hey, smart scientists, welcome back. We are in the middle of an exciting conversation with Thomas Rexer, who is the CTO of eversyn, a spin-off company of the Max Planck Institute in Magdeburg, Germany. And we are talking about glycoengineering. So if you haven't listened to part 1 yet, please go back and listen. And today we are continuing our journey on glycoengineering. And towards the end of our discussion, Thomas is going to tell us why he has now become a CTO in a startup company and what are the challenges and the obstacles of that, and why you as a scientist should also consider this exciting entrepreneurial journey. So stay tuned for part 2. Welcome to the Smart Biotech Scientist Podcast. I'm your host, David Bruhlmann. Let's smarten up biotech. Thomas, where do you see this going, the trend in glycoengineering? Let's zoom out a bit. In vitro glycoengineering, there's media optimization. As you mentioned, there are engineered cell lines. Where do you see the whole field going in the next 5 to 10 years?
So I was mentioning the glycoengineered antibodies that are already on the market, but these antibodies, they are all engineered in the same way that the focus is deleted. But this is just one way of glycoengineering an antibody and improving the functions. We also know that, for example, if we attach some sugars called sialic acids, that we can improve what I mentioned earlier, the circulation in the bloodstream. And I think this will be probably the next target, that we improve cellulation and therefore also improve the property of the biopharmaceutical.
Yeah, exciting stuff coming on the road. Now let's focus on the cost side, Thomas. So you mentioned that you are using a biocatalysis process to drive down cost. Why does this process make such a difference, and why is it significant in biotech manufacturing?
I think the really big advantage, this is very applicable, is you can really create new pathways to really convert whatever substrates you really want to use into really valuable products. And I think this is really a great point about the multistep biocatalysis. And I think in future you will see actually many products, not only in the biopharmaceutical field, but also in other areas where multistep biocatalysis is used. And in addition, what makes this approach also more feasible is that now you have many methods also to really improve the recombinant proteins that you are using, for example, by protein engineering, by using special strains for the expression. So I think this is something we will see more in future to produce valuable products.
So more specifically, Thomas, so what are the key advantages of using this technology?
The key advantages is when you compare it, for example, against using cell factories, metabolic engineering is sometimes you have a hard time of really controlling what's happening inside the cells, all right? There are side reactions you want to avoid, and this is something you can completely do by multi-step catalysis, by changing the environment where the reaction happens, by adjusting the concentrations, and therefore you're able to produce your products with a very high yield and avoid side reactions and even increase the final titer. Some limitations that you have by using cells are completely removed.
And what are the limitations of the biocatalysis?
The limitations, I would say, is you need to produce recombinant enzymes in E. coli. And if you create a very long pathway, so we typically use 5 to 6 enzymes in our pathways, and we can produce these enzymes quite efficiently. But some enzymes are not very efficient when you use them, when you purify them. There are problems like inclusion bodies and these kind of things. The activity might not be high, or when you have very long pathways of, let's say, 10 or 15 enzymes, of course, the production costs for these enzymes are very high. And I would say these are the typical limitations you encounter in the field.
And how can you now leverage this multi-step biocatalysis to create an in vitro glycoengineering toolbox?
Yes, that's a good point. What we use the multistep biocatalysis for is we produce the activated sugars. So these are the substrates for the glycoengineerings. Activated sugars, they are typically a nucleotide and a monosaccharide, and they are just like the building blocks for glycans. You can imagine this like a Lego set, and activated sugar is one building block, one Lego block that you need to build a structure. And of course, these are only the substrates, but then you also need the biocatalysts. And here we use glycosyl transferases, the enzymes that put then the Lego building block, so to say, on your structure. And here it's really important to have very active proteins that you can also express in very high titers. And you need to find the right enzymes. You can use human enzymes, or when you look for more efficient enzymes, you can use glycosyl transferases from bacterial sources. So there's a multitude of options. And yes, you just need to get the right glycosyl transferases.
Okay, fantastic. Before we wrap up this exciting discussion on glycosylation and before moving on to your current journey as an entrepreneur, I have one more question about that, Thomas. If we look at glycoengineering in general, what are the pitfalls our scientists who are tuning in should watch out for?
I think one of the pitfalls is really in the academic field, we can already tailor the glycosylation very well. We just get our glycoprotein, we dissolve it in a buffer, we glycoengineer it. But I think from an industry perspective, there's also consideration as how you can integrate it in existing production process. And I think this would be a big topic because I think typically the industry would not be very willing to change production processes or downstream processes. So I think one big consideration is how this can be integrated and if it can be integrated in production processes.
Cool. Let's talk about your journey now in your startup company at eversyn, and you're a CTO there. Can you share your journey from academia to actually now leading a spin-off, how this happened and what were the challenges and how are you overcoming them, or how did you overcome them?
That's a very exciting question. In fact, as I mentioned from the beginning, we are considering of like creating a spin out or commercializing the technology, but we are all scientists and we didn't have any clue about how we can develop a company. And I think this was really a very interesting journey. When you start to think about it, you really think, okay, how can you implement it? And then you become aware of all the things that you don't know, like financing, costs and something. And this is when you start thinking about it. And I think here it's really important to have a good environment and a good network that can support you. We as a Max Planck Institute, of course, we have, for example, Max Planck Innovations that helped us in the beginning, that also helped us to file patent applications, which I think are very important for a life science startup, but also helped us with courses and advice on how you create a business plan, how you can finance a company. And I think it's been a journey of learning very new things. And that's why I would also advise young scientists that are thinking about it, no matter whether your company works out later or not, it's really, you learn a lot. You learn a whole new skill set. You get so much insight into commercial aspects. So it's really a journey worth taking. And I can only advise young scientists to consider this.
Yeah, I like, Thomas, that you're taking the risk and just to step out of your comfort zone and try it. I like that. And as you said, you don't know everything. You have to figure it out on the go. So now I'm curious, Thomas, because as a startup, obviously you need the money, you need the funding to keep going. How do you navigate actually between investing so much time to find investors and still having time to invest time and energy in the technology development?
It's a good point, and I would like to talk about this in a moment, but maybe there's also a question for you I would like to ask you. And I understand you are also consulting, especially startups. You have consulted us very successfully. And what do you think is important for young scientists that want to take the journey? What would you advise them? What are the key first steps for them to take and how to begin the journey?
Yeah, I like that question. Thank you, Thomas. I think there are several things. First of all, if you have the desire to start a company, take the risk and learn on the go. And I see failure not necessarily as a failure. I see it as a learning. And I think take the risk, number one, but don't take foolish risks. So number two for me is find the right people supporting you. Business people who have more experience, scientists who understand the technology, maybe some finance people, but don't do the journey alone. And the third thing is don't be afraid to ask questions. I don't know why, but if it's during the studies or later in academia when you're doing your PhD, sometimes I get the feeling that you should actually know everything. And I have a completely different view. No, we don't know everything, but there is a wealth of information out there, and just tap into that and ask questions. And finally, number 4, and this is something I tell a lot of people I coach through my consultancy. I do also part of the startup coaching. We have a lot of innovation workshops. I always tell scientists and engineers, you need to learn to sell yourself, whether you like it or not. But you need to sell your idea, your technology to investors to get the funding. You need to sell your idea even to your supervisor while doing your PhD. Later in a company, you need to sell your idea. So learn to communicate and explain the science you're doing in simple terms, and not in simplistic terms, but in simple terms. That's so key.
I really like that advice. I fully agree with what you said. And this is also something that I think is absolutely essential, to have the right people at your side, to have the right consultants at your side. We were lucky to have you, which really helped us. We also had YBE, Volker Landschütze and Ursula Laconata, that really helped us tremendously. And I think those people at our side, I cannot imagine how we would have reached that point now. And that's why I would also really encourage young scientists that want to take the journey to get some good support. I think that's absolutely crucial. And you also brought up having the right team, having the right founder team. And this is also something I agree with. And maybe with this, I can come and answer your question, how to divide my time between finding funding and investing in the technology. And this, I think, it can only be managed by having the right team, right? Because this is an incredible workload, and you need to have a team that you can trust to take over certain topics, certain tasks. And I would think that we have at the moment, we have a team that we trust each other. We are a very diverse team, which I think is good, because everyone brings in a different view, a different skill set. And only with this team, we are really able to going through all the tasks which we are having now.
I'm curious about something, Thomas. Well, you have seen both worlds. So you're coming from academia, now you see the business world. And what I often observe is that there is a huge disconnect between academia and the industry. And also, let's say, even within the industry, between the R&D department and the process development and manufacturing department. So I would love to have your thoughts on how can we make the transition from, let's say, R&D into process development and then into a larger scale facility for clinical production or for the commercial production. How can we make this more seamless?
I think that's a great point. And what I can observe, I'm also involved in teaching myself. And I think from a scientist perspective, you're really disconnected from the business world. When you establish a process, you need to consider like your costs. And this was a completely new journey for us, having all these considerations. What are the costs? What is available? What does the regulatory approval look like? And I think only if scientists are also get some education on that, only then the two worlds can be connected. And I think this is a big task, and I think this should be changed, and I hope it will be changed. If you look at, if we have students from Mexico, and I think that what they manage very well at, for example, the University of Monterrey, is they really have courses on entrepreneurship and startups and financing very early. And they really, when they come here to do a PhD, they really have a different mindset. They're really eager to also think about starting a company. They're thinking about commercializing something. This is something I have observed, and I think this can be a role model. And I think also we can adjust our education system in Germany a little bit to encourage such things.
Wrapping up our conversation, Thomas, what is the number one takeaway you want people to walk away from our discussion today?
I think one takeaway, of course, I want to advertise is our startup a little bit. So if you need for activated sugars, glycans, if you're thinking about glycoengineering, please check out our website or our LinkedIn. So our company is called Eversyn. We'll be very happy to talk to you. And another point is, I think that another takeaway should be like, if you're a scientist and you're thinking about starting a company, don't be afraid, look for the right people and take a risk if you like and commercial and build a startup.
Fantastic, Thomas. Thank you very much for sharing all your insights, your expertise. And yes, please do reach out to Thomas. I will leave the Eversyn website link in the show notes. Also, Thomas is on LinkedIn, so please do reach out to him. And thank you so much, Thomas, for being on the show today.
Thank you for the interview, David.
All right, smart scientists. That's all for today on the Smart Biotech Scientist podcast. Thank you for tuning in and joining us on your journey to bioprocess mastery. For additional bioprocessing tips, visit us at smartbiotechscientist.com. Stay tuned for more inspiring biotech insights in our next episode. Until then, let's continue to smarten up biotech.